welcome to the training today. We will be talking about MongoDB. Actually, I called it MongoDB for Coder, and just just to set the expectations right. Actually, I think on the web page it's still called a workshop, but as we are so many people here, it will be not that kind of workshop where we will be sitting together in groups. It will be more like a training. So I will be giving you an introduction to MongoDB. Great, slides are coming up. I will be giving you an introduction into MongoDB, and then we have different kind of lectures. So we will talk about different aspects of MongoDB, and these lectures are always followed by some practical examples, which you can do on your own on your laptop. So we will have a certain time box for this labs. Everybody will be doing the labs on his laptop. Hopefully, learn something about MongoDB in that time, and then I will continue with the next lecture. So just to set the mood right. So if you're feeling you're being tricked into something, you still have the time to go out. And actually, as I will be talking for most of the day, feel free to, if you don't like a particular part, so just go on, have a look at the talk, then come back. I'm perfectly fine with that. And yeah, so actually, it's all about you. You can make it as interactive as you want. So, of course, shoot me any questions, and let's make it your training. So actually, who am I? Name's Seiler. I'm standing here because I'm kind of a big data nerd. I'm working in that area for quite some time now, especially in the area of Hadoop. I'm giving Hadoop trainings as well. MongoDB actually was something like my initial starting point with the whole big data field, with the whole NoSQL field. I'm currently writing a book on MongoDB in German. And here, in my spare time, I'll very much like traveling and taking pictures and stuff like that. So that's me. That's CodeCentric. You should know by now. I don't need to tell you anything about CodeCentric. We're a bunch of really cool guys. You should know that by now. And you should join us. That's obvious. We're always looking for good people. And we had a discussion about, so the two principles would be, you need to be extremely good looking, because look around, all the CodeCentric guys are extremely good looking, and you need to be some kind of crazy with a light tendency to insane. If that's you, then you're perfect to join us. Okay, but now, what are we going to do? Like I said, this is, I declared a starting to intermediate level. So if you have never heard anything about MongoDB, that's perfectly fine, because that's what I will be giving you an introduction to. So if this is your first meeting point with MongoDB, stay in the room. That's perfect. You're good here. And if you already have heard about MongoDB, I hope I have something for you as well, because we will start with some more basic stuff like CRUD operations, etc. But then we will move on to some intermediate stuff like indexing, how you can speed up your queries with MongoDB. We will talk about best practices there, and you will, of course, yourself will try to speed up some queries and stuff like that. And as I said, I'm very much dealing with big data. So we will talk about MapReduce, which is a great pattern for dealing with big data and getting insights out of the data. Then we will be talking about the aggregation framework, which is something special to MongoDB, about how to deal with big data and getting aggregations and insights out of the data. And then for the remainder of the training, we will move on to some more operational stuff like replication. Replication is how you make MongoDB highly available, how to set up this. So, for example, in this exercise, we will set up a replica set with 3 nodes and make sure that when one node goes down, the data is still accessible, something like that. And one of the big points about all this big data is scaling. So that's the last part we will be looking at. In MongoDB, it's called sharding. This basically means horizontally scaling. So that's what we're going to do. Like I said, I have lots of slides. I will do some live coding. Of course, I encourage you, please, if you have something, always talk to each other, talk to me, talk to your colleagues, and yeah, we will be doing some labs on your own computer. So if you have MongoDB already installed, that's fine. If not, we will be covering all of that. Yeah, already encouraged you a lot of times, so hopefully it works. And now, as I said, I will start talking a little bit right now, giving you an introduction. But in the meantime, it would be good if you can already start to download the lab files. Actually, these are the lab files. These are about 17 megabyte. Hope the network is capable of that everybody can download the lab files. These are just the installation files. So if you haven't installed MongoDB on your computer yet, that's what you would download, or actually you could just go to the MongoDB.org website, have a look at the download site, and yeah, get the appropriate version. So that's maybe the thing I should write down here. We will need it. So perfect. Okay, and the installation. Come on. Not working at all. Can you read that at all? Not really, or? Okay. I thought so. Maybe here it's the pencils suck, but still not getting much better, huh? But we will work it out. Otherwise, take out your phones, take a picture, and not working at all. Okay, but I assume by now everybody has typed in this URLs or has written it down in a text editor or something like that. So that's a good thing. Actually, the only thing I only have one USB stick. So if you want to go faster, then just hand this around. If you download the files for yourself, we can make this work. Okay, everybody got noted down the URLs? Yeah. Okay. Then I can start the buzzword bingo. That's the introduction. Because usually when we're talking about big data, MongoDB, NoSQL, there are lots of buzzwords here and lots of marketing, to be honest. So I want to just set the stage here and talk about some stuff. As you know, MongoDB is a NoSQL solution, or it's in the area of NoSQL. Probably all of you have heard the term by now, and so NoSQL does not mean that SQL as we know it is now doomed. We don't like it anymore, and SQL is bad at all. NoSQL actually just is a bad term, and it's just trying to say that there are some solutions out there that are not only relational. So the relational database model has been around for over 40 years right now, and to some point, especially in the 90s, people were just totally fixated and concentrating on the relational model, and now the whole NoSQL idea is, hey, why don't we get some other solutions to some specific problems? So maybe the relational model is not the only thing that's good to store data. That's basically it. And in doing so, there's something like a classification of NoSQL solutions. Probably you've almost everybody has heard the names by now. So the most simple solution would be something like key value stores. This means you have simply a key, a value. Most commonly known is Redis, or React is also quite popular. So it's a very simple data model behind it, and if you need some really fast storage, you would go for something like a key value store. Another model in the NoSQL world are the column stores. They are actually based on a model created by Google. So it's called Bigtable, and it's a little bit like a relational model. You see all these columns there, but you also see there are some spare fields here. So it's like a more intelligent version of a relational database model. The most common ones are Apache HBase, you've probably heard of that, or Cassandra. These are the popular solutions there. Then another class of NoSQL databases would be the graph databases. Probably you've heard of Neo4j, that's the most common one. And this is really, graphs. So most of us should have some computer science background. And back in my days, we had all these lectures about graphs, etc. And this is exactly what we heard back in university about graphs. So you have your nodes, you have your relationships between nodes, and you can use this to model data with that as well. So of course, the most popular things are something like social networks, which just perfectly fit the model of graph databases. The typical Facebook example, you have people, they are interconnected, etc. You can perfectly model that with graph databases. And now what we're going to talk about today are the document stores. So this is MongoDB or CouchDB, for example. This is, you store your data as a document. So basically, you have a key. Your document has a key, and then you have all your values you want to store in one document. For MongoDB, the choice is JSON, but here you could have different document models there as well. So another thing, big data. A big buzzword. Actually, I think it's too much of a buzzword right now. Everybody's getting fed up with it, because the marketing is using it very extensively. So yeah, there are a lot of definitions. This is my favorite definition when it comes to big data. It's just big data is when the data itself becomes part of the problem. So this is some kind of a very universal definition, and it's simply about, okay, when you have to deal with the idea about how to store data, then maybe you're dealing with big data. So that's it. So this means, this is the more classical definition. You should have heard it in talks yesterday, but I think Dusan had it and some other talks. This is the classical Gartner definition. This means we're talking about big data. If we're talking about big volume of data, meaning like terabyte and petabyte of data. This, of course, means some problem. I mean, it's not that easy to store petabyte of data and to access it easily. So we're running into a lot of problems there which need to be solved. And then another thing would be the velocity of data. This is the typical, data is getting generated faster and faster these days. We have all these social networks, not starting with sensor data, smart metering, stuff like that. So machine data is being created at a much higher velocity nowadays. So it's just, we need to react to data much faster than it was like 10 years before. And another thing is the variety of data. This is the classical, okay, like I said, the relational system has been around for quite a time because it was possible to put all the data, to model it in some way that it fit into something like the third normal form, etc. You could model all that. But nowadays we're talking about semi-structured, unstructured data. Just think about Twitter, for example, a tweet itself. It has some kind of structure, but you cannot tell exactly. So it's a little bit of a semi-structured data. And then starting with all log files, etc., we're getting into more and more into the area of unstructured data. So this is the problems these are the problems we are dealing with here. And actually, when you hear big data, you most certainly hear Hadoop within a sentence. Hadoop is the most popular solution for dealing with big data, but it's not the only solution. So, for example, you can consider MongoDB. You can call it a big data solution as well. So, whenever, like I said, whenever you want to have some problem storing the data or dealing with the velocity of data, this is something like a big data problem. And actually, so it's not only Hadoop when we're talking big data. One thing to understand about all these solutions is the fundamentals of it. So there are like 2 or 3 principles you need to understand which are common to all of these big data solutions. The first one is the horizontal scaling stuff. So in prior days, it was like more, okay, we had our computers, we had our servers. They were equipped with some RAM, CPU, storage. You had a problem. You were running out of storage. It was too slow. So what did you do? You just did scale up. So you bought a bigger machine. You put in more RAM. You bought a bigger CPU, something like that. And this just got on. That's the classical solution to dealing with performance issues, storage issues, etc., and all those needs. So that's the classical solution. We've seen that for a very long time. The classical coming from mainframes, classical servers, etc. That's one thing you can do. But on the other hand, you can do something like horizontal scaling. This means, you have your server. You're running out of CPU power, something like that. So what can you else do? You can just add more machines to it. So this is horizontal scaling, and you can add even more machines. And this, of course, implies some problems, because now you have the problem. First, when we were vertically scaling, we were all on one machine. We had one context. So now we're having like server farms clusters with 5,000 machines. And you need to synchronize all your data between these clusters. The communication will imply some overhead. And you have to think about, okay, how to store your data on all of these different machines. You need to split up your data, stuff like that. You have to handle all the failover stuff. So what happens when one machine is failing? Of course, you don't want to lose data and stuff like that. So these are all the problems which these big data solutions need to solve. So Hadoop does it. MongoDB does it in one way. We will talk about that today. So we'll see about that. And actually, when it comes to distributed data, maybe you've heard of the CAP theorem. It's quite popular. Actually, when you're dealing with big data in any way, you will hear it within the first half hour, like today. It basically says when you have a distributed system, you have 3 needs. So you have the availability, that's the guarantee that every request receives a response. Then you have the consistency. This means when you have a big cluster of computers, it's making sure that all nodes see the same data at the same time. And then it's the partition tolerance. That's what I just said. If one node fails in a cluster, you want to make sure that it doesn't affect the overall system, so the system just keeps running. And now the problem with that is, for a distributed system, it is impossible to simultaneously provide all of these three guarantees. So these are like concurring, yeah. Oh, come on. Yeah, you know what I want to say. I'm just missing the word right now. Sorry. Okay, and so the thing is, what the CAP theorem says, it's only possible to pick 2 out of these 3. So it's always, you have to make some compromises. You can never fulfill all of these 3 abilities, but you have to pick 2. And when you have a closer look at that, how it is mapping to NoSQL system and actually to SQL systems, we're seeing the classical databases. They're up here in the upper left corner. So this is our classical Oracle, DB2, stuff like that. They are in the area, they're guaranteeing you availability and consistency. So you will always have the data available, and it will be consistent throughout all the nodes. But when it comes to partition tolerance, we know classical databases, they don't scale that well. I mean, Oracle is having its RUG solution, etc., but it's very expensive and it does not scale up to like 10,000 computers. It's more like, okay, you can connect 8 servers and then put in some more data there. But yeah, it's not really a cluster system. So they're missing the partition tolerance ability. And when it comes to MongoDB, we can see it's down here. So this means MongoDB is making sure that all nodes see the same data at every time, and it's partition tolerant. But when it comes to availability, this means when there is a failure in the system, it doesn't ensure that every request gets a response. So that's the drawback with MongoDB, and that's the design decision they had to make when they their system. And there's some other combinations here. Actually, every of these systems had to think about it. So what's my design? Where do I want to set my priorities? Because it's only possible to pick 2, not to fulfill all of these abilities. So that's it. Then we're coming to the problem with consistency. You all know ACID. It has been around for a long time. Classical databases. Actually, we all heard it in lectures because it has been around for such a long time. It's a classical transactional thing about databases. It's atomacy, consistency, isolation, durability. I don't think I need to explain that. Everybody of us should know that by now. But now, what all of these NoSQL people were saying, ACID itself is a very good concept, but it's not a written law. And in the last years, you had the impression it is something like a written law. So every system, every database system needs to be ACID compliant. Otherwise, it's not good. And that's exactly one big plus all these NoSQL guys were doing. They were saying, okay, ACID is fine, but maybe there's something more to it. And so that's what they're doing here. And actually, they try to build some acronym here. It's called BASE. This means basically available, soft state, and eventually consistent. And the important part here is the eventually consistent. So with classical database, with ACID systems, you have a strong consistency. This means you can be sure that your data will always be consistent. You query a database, you will always get back the same result. That's one thing. But now with NoSQL systems, it's eventually consistent. This means we have clusters. Maybe not all not all nodes of the clusters have the same information at the same time. So if you ask maybe now for some information, you get one point of truth. But if you ask 1 second later, you get another point of truth, and you cannot be that sure about that. You always get the same response to the same result to the same response. So this is what eventually consistency is about, and this of course implies some more problems which we as a programmers need to deal with. But we see about that when we talk about MongoDB. And actually, that's my point. Coming to MongoDB. Actually, is there someone in the room who hasn't heard anything about MongoDB? Okay, you're all too shy. Yeah, thank you. No, but I think the MongoDB is doing a very good job of marketing. They're the typical American startup company. They're getting fundings a lot more. I think they're now in the 4th round, and they had something like 150 million additional funding just 2 weeks ago, which is just an insane amount of money. The company itself is valued by far over $1 billion by now. So they're doing a great job of marketing MongoDB, and actually that's what they're doing. They're putting a lot of money into marketing, into educating people, so they themselves have a lot of free online courses. They're constantly building up community, etc. So they're doing a great job there. So that's why I was asking, because by now everybody should have heard of MongoDB. Like we just found out, MongoDB itself is a document database. It is open source. It claims to be highly performant. It's flexible. It's scalable, and it's highly available. Of course, and feature-rich. I was missing that one. So we see about that in a few minutes. What do I mean by database? Like I said, it's not like, okay, we store like PDF files or Word files in the database, but the data we store in MongoDB is a document, and they did go for JSON. You can recognize this is the typical JSON here. So whenever you want to store your data in MongoDB, it looks something like this. So you have your key here. You want to store information about the author, and you have your key, and you have your value there. So it means, okay, we know we have some information about an article here. The author is Roger. It has a date. It has a title. It has a body and some text to it. Pretty understandable. Pretty human readable. Good thing to do. Actually, MongoDB itself, when you interact with MongoDB, it's JSON, but internally it's stored as BSON, which means it's just a binary interpretation of the JSON format, just to make it a little bit more performant, as this will all be stored as memory mapped files. So binary format is better, but of course, yeah, not human readable. MongoDB itself is an open source project. So it's available on GitHub. Everybody can have a look at the source code. Actually, it's using the AGPL license. It was started and sponsored by MongoDB Inc. Actually, they just changed the name like a month ago. Prior, it was Tengen, if you heard that name before. And there's also a commercial version available and some additional support. I mean, that's clear. Every company wants to earn some money, but the commercial version, there's not a big difference between the version and the commercial version. It's mainly about some enterprise support stuff, something like stuff, etc., which big companies need, but which you don't need in your daily work. And of course, as all agile companies, you can join the crowd. The Jira is up. It's actually good looking at those Jira tickets to get an idea of what they're currently working on, because a new major release is coming up right now. So we're at version 2.4 right now. 2.6 is coming up, and there will be some major stuff in it. So if you want to dig deeper into it, go for the Jira. Okay, and when when we talk about MongoDB, everybody is bragging about the performance of MongoDB. Everybody is saying it's very fast. It allows you to store your data in a much faster way than when you use an Oracle database or something like that. And of course, this has some reasons. One reason what they're trying to do internally is they're doing a lot of data locality stuff. So internally, this is all memory mapped files. I mean, at some point, you need to store it to a hard disk. But of course, you're trying to keep all your hot data in your memory because you can get faster access to it. But at the end, there are some accesses to a hard drive needed. And so it's better to store all your data locally together, because this would basically mean like 3 calls to the memory, to the hard drive, which is bad. And this would be like 1 call to the hard drive, which of course is much faster. Then I already pointed out what they're doing is a lot of in-memory caching. So for MongoDB, it's always best to put in as much memory as you have available, because that's, I mean, with most of these big data systems, it's all about memory, because memory is by X times faster than hard drives. We all know that. So of course, writing and reading data from your memory just speed up everything. And the last thing they do is something like in-place updates. There's some clever mechanisms so that updates, writes to MongoDB are also, can be done rather quickly. So it's not only reading data quickly, but also writing data very fast. Another thing they point out constantly is the flexibility you have with MongoDB, and this comes from the document model they chose. Because here, in old days, it's like this. Maybe you all know these entity relationships, etc. When coming from a relation database system, you had to think about your model, had to think about, okay, which tables do I need? How do they interconnect? Where are my foreign keys, etc. So you had to do a lot of planning upfront before you even started to put data into your database. So MongoDB is going another way. They're saying, okay, actually, we don't care about your data model. We're very flexible about it. So actually, with MongoDB, you can put basically everything together in one database into one collection. So it means you can actually put counting data, your CVs, you can put logging data. If you want to do it, you can put it all into one collection, into one table, something like that. MongoDB is not enforcing you any structure. So this means you have a great flexibility here, especially when starting up. You just start to put data into MongoDB, and then at one point you see, okay, maybe I want to add some new values here. Maybe what are we talking about here? Yeah, I want to add the gender of the person here, for example. This is no big deal in MongoDB. You don't need to update the model or something like that. You simply just start putting the updated documents into MongoDB. MongoDB will not complain at all. And so you have a great degree of flexibility or freedom here what to put into MongoDB. Of course, this on the other side, with great power comes great responsibility. This means you shouldn't do that. So you shouldn't use the flexibility to put everything into one collection. You need to follow some principles for schema design as well. But it's really much faster. It's not like 2 weeks planning and then you start putting data in. It's more like, okay, I think about it for 1 hour and then I start putting data in it, and then it just perfectly fits the iterative model, the agile model. So that's also a reason why MongoDB is so popular right now. Scalability, this is exactly what I was talking about, horizontal scalability. It's built into MongoDB. In MongoDB, these horizontal nodes are called shards. So it's called sharding. It's built into MongoDB. It's out of the box. And actually, it really is just put in some more computers, do some configuration stuff, and data will be distributed across those shards. no big deal at all. So that's a good thing because operational side of MongoDB is quite easy, because at least if you're not digging too deep into it. Of course, you don't only want to scale your database, but you also want it to be highly available. So this means in MongoDB, this is called replication mechanism. This means you have different modes about how you can write your data. Basically, it means you have something like a master node and some slave nodes. In MongoDB, they're called primaries and secondaries, and there are mechanisms to set those up. So this means you have a replica set here with 3 nodes. They're doing the election stuff, etc. You have one primary. You usually you read and write data from that primary, but yeah, if one node goes down, they automatically will select another primary, and that makes sure that you always have access to your data. So that's one good thing. It's also built into the box and no big deal to set up. And so if we're talking about production systems of MongoDB, this is something like a typical architecture you're having. You're interacting with MongoDB using your drivers, something like that. Actually, there are drivers available for, I don't know, by now it should be something like 35 different programming languages. They're very good at that. Then you have something like a query router, which is yeah, like the name implies, it's just routing your requests. Then you're doing the horizontal scalability stuff, so you're having different shards here, and to be highly available, one shard is usually a replica set. So this means you combine the concepts of sharding and replication to scale and to make sure your data is always available. So this is how you set up a MongoDB cluster. The query language itself, it's very rich. So basically every functionality you know from your classical SQL systems, you can do it in MongoDB with some, of course it's not the same thing. For example, you can't do joins, so the concept of joins, they're not built into MongoDB. There are other ways to cope with that, but yeah, the classical stuff, getting data out of it, doing selects, etc., it's all built in. A good thing is aggregation framework. It's a built-in framework into MongoDB. You can use it whenever you need to aggregate data. So meaning what's the classical example? It's more like you're having your terabytes of log data and you want to get some specific information out of it. So this is like a pipelining concept. You're constantly narrowing down the data you want to get out of it. But actually, we will have a look at that. So just leave it like that for now. We have MapReduce, which is not only in MongoDB, but this is also a popular concept about how to deal with big data. We will learn about that today as well, so I'm skipping that. It has built-in geo-information systems, so the classical 2D points, 3D point stuff. For example, for visualizing something like, I think this was a Twitter heat map, something like that. So you see, okay, yeah, a lot of tweets are going on in Turkey, so it must have been during the riots, something like that. So that's built in MongoDB as well, no big deal. Talked about the drivers. A lot of drivers are available, and one way to interact with MongoDB, what we will be doing today also is there's just a simple shell where you can do all your querying, etc. on MongoDB. And if you needed any more motivation to dig into MongoDB, actually you're still motivated. I'm surprised. MongoDB nowadays is really becoming one of the skills companies are looking for. So if you're looking at Google search, if you're looking at the LinkedIn job skill index, or there's some other indexes, so you see it's like HTML5, MongoDB, iOS, Android. These are the skills companies are currently looking for. So yeah, it's good to stay here and maybe get a bit bigger paycheck tomorrow. No, not going to happen, but okay. Then that actually this should lead me to taking a sip of water. Okay, great. So now I've talked a lot about MongoDB. I must have sounded like a sales representative of MongoDB. I am not, but I just like it. So sorry, I'm not trying to sell you anything. So now let's dig in a little bit deeper, and we'll start talking about data manipulation. So first, we need to talk about a little bit about terminology. It's a little bit different. So when we are coming from a relational database world, we all know our tables, views. We have a concept similar to that in MongoDB as well. It's called a collection. A row in a database would be, in MongoDB, this would be a document. We have indexes as well in MongoDB. So like I already said, joins itself are not possible in MongoDB. So you cannot do something like join document 1 with document 2. So this is by design. This was an active decision to enable this horizontal scalability. This is not possible. And actually, what you're doing in MongoDB is, in classical systems, you're very much looking for data integrity and not storing data redundant. So you want to store one piece of data only one time in your database. With MongoDB, it's okay. I don't care. A hard drive, etc., is cheap. I want to store all the data I need for one query in one place. This could mean that I store data like 5 times in different places, just to make sure that I get all the pieces of data within one query. So this is a whole different way of thinking, and we will see about it. We have some examples. For example, we will have a look at Twitter, how a tweet is built up, and you will see they're making a high use of that. So same data is stored very often in a document. So that's the way how you do joins in MongoDB. You have something like foreign keys. You can reference documents, but it's more of a logical thing. So MongoDB doesn't take care about the integrity. So you have to define the references for yourself, and you have to take care about them on application level as well. And we've talked about shards. So this is how you partition data up in MongoDB. And now, to start this, we will use a simple block model for this part. So this means we have some collections here. Remember, a collection is something like a table. So we will have a table with users that I will show you right now. Then there will be a collection with articles. We have a collection with tags and a collection with categories, something like that. So this is how you would model that in MongoDB, or how you can model that. You have your user, your user documents, your users identified by name and email address. Then you have your article. It has a name, of course, text, something like that, an author. And inside, like I said, you're using embedded documents quite a lot. You have something like a comment and tags and categories. So this would be one way how you could model this in MongoDB. Okay, and now we're having a look, and I should sit down. Let's see. Yeah. So, hopefully you can see anything. I love it when it messes up. As you can tell, I'm a total desktop messy. There is the one I thought. So what I was too fast. So what I'm doing right now, I'm just starting up an instance of MongoDB. Actually, I have it scripted, so it's basically just very easy. I'm calling the MongoDB process here, telling it where the data is, which port to use, and some other stuff that it doesn't need so much data. So that's what I'm doing. So this is like starting up my MongoDB. Fine, it's running in the background, and then I'm starting another command line. And yeah, now basically I just connect to MongoDB. So this means, yeah, I played around with it. Ignore the warnings as always. So, and this now means now we're connected to MongoDB and we can interact with MongoDB. So this means it's running in the background, and this is our Mongo shell. We can do stuff inside here. So first thing maybe to do is have a look at the databases we have. It's something like show DBS. Is it possible for you to read it, or should I? Even in the, you can read it on the back as well? Yay, great. So you see, I've played a little bit here. So I have different databases here, like my blog database. I have something like my Twitter database, some test stuff, etc. So okay, that's fine. So now let's say I want to use my blog database. I'll jump into the database, and then I can do something like, okay, have a look at the collections. Perfect. So we see we have a collection user here, and we have an automatically created collection with the indexes. There's something like a default index on MongoDB, so this will be automatically created. But actually, let's see, what did I want to do here? Actually, let's just drop the database. Okay, so now if I want to insert data into my database, remember we're at the blog example, so we have some users there, and maybe you will recognize Sheldon from Big Bang Theory and all the other guys. Hilarious show, I love it, so I used it for this example. So now if I want to insert data, it's rather simple. I'm just saying, okay. Oh, come on. Why is this not working? No. What's going on? What's going on? No copy and paste. This is, okay, now it works. This is why I like live sessions. So now what I'm doing here is basically I'm just telling MongoDB to insert data into the user database. So DB is something like the namespace you have to use for the commands. Then I'm telling, okay, I want to insert something in a database into the collection user, and I want to do an insert, and then I insert my JSON document. So now I'm inserting a JSON document with a attribute name and a attribute mail with according values. So I'm just doing this. You see, no reaction at all from MongoDB. So what MongoDB did, it just inserted the data. So I will insert some more data here. Actually, I'm constantly switching between data and data. I don't know. Actually, I've been told data is the hipster way of pronouncing it. So all the cool hipsters in New York are doing it. So I will stick with data. Okay, we can argue if hipsters are still cool, but yeah, we see. Okay, now I basically inserted some data into MongoDB, and now we can have a look at it. So again, we have a look at the collections. I see, okay, there's my user collection, which I previously deleted, and now I want to see what's inside inside the collection. So I can do something like a find one. This just returns one example document, and actually it was the first one I inserted. So you can see my data got inserted into MongoDB, and you may recognize here, actually I just put in a document with a name and mail. Oh, where's this ID coming from? So this is something like a automatically created ID from MongoDB. You see it's an object ID, and actually this is something built up out of the namespace of the database. You have some time components in it. So MongoDB makes sure this object ID is unique throughout the whole cluster when you're using it. And yeah, so this is automatically created for you, and actually there's an index on this ID as well. Okay, what else can we have? Now we don't want only to find one, but now maybe we want to find, come on. Why is it? Okay, now what we can do when we use the command find, we can do some sort of filtering. So what I'm doing right now is I'm querying MongoDB for all documents where the name is Penny. So we're doing this, and as expected, MongoDB, as a result, I get a document where the name is called Penny. So, and actually I can do a little bit more. I can maybe if I just want not the whole document, but only parts of the document. Oh, come on, why are you kidding me? So now, for example, this means I did a projection here, so I still queried for the document named Penny, but I didn't want the field ID to be displayed, and I did want only the field mail to be displayed. So that's what I'm getting. I'm just getting the attribute mail out of that document.